last piece of the puzzle here for, I'm going to do the vector stuff. I'm just going to walk you through. I did the work on this page for second two of that review, or the second page of that review. And here's the airplane one. Let's break it down into chunks here. So it gives us a plane with a specific bearing from north 45 degrees toward the east at 600 miles per hour. So I have those separated out here. So remember, you start from the first direction toward the second direction, the said number of degrees. Turns out this is also the same as the direction because it splits it in half. But usually you don't use that given angle, especially when it's broken up by that type of bearing notation. But in this case, it worked out. So we get a direction of 45 from 0 as well. When you do the wind, however, it's from north 10 degrees towards the east. So that's a direction of 80 degrees because you're going back from 90, 10 degrees. So those are the directions we need to use for our respective vectors because we want to do calculations with direction angles. So I've got those drawn separately, and then when I put it together, that's, remember, part of the test will have you drawing the combined vectors. It means putting that wind vector with its direction and the plane with its direction and putting the wind on the tip of the plane. You get that resulting green vector, the sum vector, which should be longer and a little bit more towards the north than it was to begin with because the wind blew it off course. To find out what the green vector looks like, we add the red and the blue, their x and y components respectively, and I used a calculator to do that, so I get these values. You can certainly check against those. And then you have to get the direction and magnitude of that resultant green vector, which you do inverse tangent. Since this resultant vector is in the first quadrant, the inverse tangent will be correct. I don't have to add 180 to it, and you can even see that from the picture. And then the magnitude is 641, which is faster than how I started. So it's a little bit more north than its original bearing. So 45.56 degrees means it does further north than its original 45 degree setting. And then it's also faster than 600. It's now going 641 degrees, or 41 miles per hour. The wind was 50 miles per hour, but not all of the wind was applied to the plane because it was a little off center. Okay, so now if we get on to the next one, are these angles perpendicular? I'm sorry, no, are these vectors perpendicular? So I drew the two vectors. So if you look here, the green and the blue are the 8, 5 and the negative 4, 3, or negative 3, 4 vectors respectively. I need their direction, so I did inverse tangent of those. Notice the red vector is in the second quadrant, so when I got my inverse tangent value, it was facing the wrong way. So anytime you have vectors in the second or third quadrant, you're going to have the angle from inverse tangent will be facing the wrong way. So you add 180 to it, it's 126.9. Then the green vector is facing in the first quadrant, inverse tangent is correct. So are those vectors perpendicular is a matter of are they 90 degrees apart. If I subtract their directions, they're 94.9 degrees apart. That's not perpendicular. So in the end, it's not perpendicular because the angle between them is not 90 degrees. If you looked at the homework explanation, it used this formula for angle between involving what's called a dot product and some other information. No need. If the concept is just the angle between, there's a formula. If you ever wanted to learn that formula, you certainly could, but let's just keep with what we know. Get the angles of each, find out how far apart they are. Then the bonus one is not really a bonus, it's right up the alley of what we've been doing. The thing is I have a vector force 5 meters per second and force 3.5 meters per second. I've drawn them in red and blue. I add them together to get their combined vector value. And the drawing of that, of course, is when you slide that blue vector to the tip of the black vector, or the red to the tip of the blue, doesn't matter. The resultant vector will be the one that we're finding. And so the components you see right here for that green resultant vector, 0.56 over 7.8 up, sounds reasonable. The magnitude of that is 7.82 meters per second. But that's not what the question asks for. It doesn't ask for the magnitude of it. It asks how far would you travel in a minute. And since this is measured in meters per second, that would be 60 seconds of travel at that rate. So you just take 7.82 times 60. And I showed the unit analysis there and why we get meters. But meters per second times second produces the number of meters. 469 meters would have been the amount of distance traveled. So that is the end of that review. I posted the PDF of this as well, but feel free to ask questions as you're working through this stuff. See you guys on Monday.